Hello viewers, Wagadaru now taking you through the tutorial for A-Level Subsidiary Mathematics, and this video will be on Surds, and this video is suitable for students in both Senior 5 and Senior 6 offering Subsidiary Mathematics. So expressions such as root of 4, root of 9, root of 16 and so on can be evaluated exactly and have exact numerical values. For example, square root of 4 is plus or minus 2, square root of 9 is plus or minus 3, square root of 14 is plus or minus 4 and so on. However, there are some expressions such as square root of 2, 3, 5 and so on which cannot be evaluated exactly and hence can't be written numerically as quantities. These are irrational and can only give decimal approximations. For example, if you press square root of 2 on your calculator, you'll be able to come up with this value. If you press square root of 3, you'll come up with this value. If you press square root of 5, you'll come up with this value. So these irrational expressions are what we call surds. And they often arise in calculations, and it's often preferable to leave an answer in surd form instead of a decimal approximation. But the surd form but to leave it in surd form, you must ensure that the surd is not in the denominator. However, expressions involving surds have to be simplified following certain rules. So there are some rules which you need to know when we're dealing with surds. So now let's start with the reduced form of a surd. So you have said that surds can be reduced to their simplest form if. So this word is if. So if the number under the square root sign is a product of a square number and any other number. For example, if I have the square root of a squared times b, it can be reduced to become a square root of b. For example, if I have square root of 175, 175 is the same as 25 times 7, but this is a square number, therefore it is the same as 5 squared, and therefore in the end you come up with 5 root 7. The next is multiplication and division of surds. So surds of the same order can be multiplied or divided. For example, if I have root a times root b, the same as root of a times b under the same root. Then also root a divided by root b is the same as square root of a divided by b. For example, if I have root 7 times root 2, it is the same as square root of 7 times 2, which is square root of 14. And also root 15 divided by root 3 is the same as square root of 15 divided by 3, which is the same as root 5. So furthermore, this times this, it implies that these ones outside can be multiplied together to come up with this, and also these ones inside can be multiplied together to give you that. For example, if I have this, it implies that this times this gives you this, which is 6, and also this times this gives you this, which is root 14. Then next we shall go to addition and subtraction of surds. Now surds of the same order with the same number under the root sign can be added or subtracted. For example, this and this, we realize that this is root c and also this is root c, meaning that you can add them by saying this time plus this gives you that, and this one is maintained. In other words, factorize out root c. Similarly, this minus this implies that this and this can be subtracted because you have factorized out root c. For example, this will give you that because this is 7 plus 5 gives you 12. Then your 7 minus 2 gives you 2. So that is how they subtract or add in this, or add surds. But remember, you must be keen, because when it becomes root a plus root b, there's no way you can add it, and also root a minus root b, there's no way you can subtract it. So then now let's just go through some of the questions. Question 1 says, without using tables or calculator, simplify this. So first of all, we have to remember that to simplify them to be a product of a square number and any other number. So this 243 is the same as 81 times 3, 108 is the same as 36 times 3, 75 is the same as 25 times 3. So these are square numbers. Therefore, square root of 81 is 9, that is why you see 9 here. Square root of 36 is 6, that is why you see 6 here. Square root of 25 is 5, that is why you see 5 there. Then next, this minus this plus this gives you this part. And in the end, you shall come up with 8 root 3 as the answer. Then question 2 says simplify this, leaving your answer inside form. So this one, 45 is the same as 9 times 5, 20 is the same as 4 times 5, 80 is the same as 16 times 5. Now these ones are square numbers, so inside one should be a square number and one should be, and the other should be any other number. So square root of 9 is 3, that's why you see 3 there. Square root of 4 is 2, that's why you see 2 there. Square root of 16 is 4, that is why you see 4 there. So next I'll simplify. This gives you 6, and then this plus this minus this is this part, therefore answer will be 4 root 5. Then question 3 says express the following in the simplest form. Now this one, 288 is the same as 144 times 2, this 2 is maintained. 72 is the same as 36 times 2. Therefore square root of 144 is 12, that's why you see 12 there. Square root of 36 is 6, that is why you see 6 there. The next is this plus this minus this to come up with this part, and the answer will be 13 root 2. Then question 4 says express this in the form a root b. Given that root 2 is 1.414, evaluate the above expression. So this is what is given. Then from here I realize that this one can be simplified to become this, and this one can be simplified to come up with this, and also this one will be simplified to come up with this. I believe by now you know how to simplify them. So next is to collect like terms, because this is root 2, root 2, root 2, root 2, therefore it will be this 10, which is here, minus 3, plus 20, minus 6. And then you come up with 21 root 2. So it is already in that form. But they told us that given root 2 is equal to that, evaluate the above expression. Therefore, the above expression will be equal to 21 root 2, which is 21 times 1.414. And when I use the calculator, it will become this. Then question 5, without using a calculator, evaluate this. So when they say without using calculator, it means that they want to see the laws of Surds being applied. So this is what is given. This will be maintained. But this 40 is the same as 4 times 10, and this 20 is the same as 4 times 5. Therefore square root of 4 is 2, that's why you see 2 there. Square root of 4 is 2, that's why you see 2 there. So this is 6 plus 4, which is 10, and this is 2, which is there, and this times this gives you root 10, which is there. Now this can cancel to remain with 10 over 5, which is, 10 over 2, which is 5. And question 6 says given that t is equal to this, show that t squared is equal to 1 plus t. Therefore we shall start from the left hand side. T squared is equal to the whole of this squared, which is that. Then when I expand, it will be giving me that, because this half becomes a quarter, and expanding this one gives you this. I hope you remember the expansion of a plus b squared. Then when I collect like terms, this plus this gives you 6, and this is maintained. But remember, t is t, inside there is only 1 plus root 5. So this one, what I've done, this 6 and this 2, they have something in common, and that is 2. Therefore 2 can be factorized out to cancel with this, to cancel 1 2 here to remain with a half, and the inside will remain, this 6 will become 2, so it will become 3, and this 2 will become 1. But in our expression for t, after this root 5 there is only 1, that is why we are going to split this 3 into 1 plus 2. Then we split it, this 1 times a half to give you this, and this 2 times a half to give you that. Then this one is 1, and this one is t, and basically that is what they wanted. So now we shall go to rationalizing the denominator. So the process of converting an irrational denominator to a rational one is known as rationalization. When fractions are involved in surds, it is normal practice to eliminate the surd from the denominator. Like I've already said, the answer can be left in surd form as long as the denominator does not have a surd. So in case the denominator has a surd, what you need to know is how to rationalize. So this is what we are going to deal with. So this is called rationalizing the denominator, and the aim is to ensure that the denominator is clearing of irrational numbers, now that it doesn't have any surd. Now let's start with case 1, whereby you have an expression of the type 1 over root a. So for expressions of this type, we multiply the numerator and the denominator by root a. For example, if I have 1 over root a, it means that I have multiply up and down by this root a to come up with root a over a. And in this case, I think we realize that the denominator does not have any surd. Now that knowledge, let's go through some of the questions. Question 1 says, simplify this by rationalizing the denominator. So rationalizing means that you multiply up and down by this one to come up with this step, and here we realize this 2 is maintained. Now 2 times 8 gives you 16, and 8 times 8 gives you 64. Therefore in the end we shall come up with 2 times 4 over 8, which gives you 1. Question 2 says, show that this is equal to root 2 over 2. So here they have to also remember the knowledge of surds. So this one is the same as 5 to the power 2. And also this one, you realize that 5 to the power 6 is common, so inside you shall remain with 5 to the power 1 minus 5 to the power 0. So how does it come about? Now to get this one, you say this divide by this. So when I divide, same base subtract the power, will come up with 5 to the power 1, which is there. Then this minus is maintained. Then this divide by this, same base subtract the power, you come up with 5 to the power 0. Now this one is the same, it will become this because you multiply the power, so come up with 5 to the power 6. And here, this is 5 to the power 6, and this minus this. Remember, this is 5 minus 1 gives you 4. Then this times this, it becomes 2 times 5 to the power 6, and this one is maintained here. Then you are going to cancel out, because this and this cancels. Then this 2 divided by 4 gives you a half. That is why I see a square root over half. But remember, in this square root over half, root 2 is in the denominator, therefore you have to rationalize. So multiply up and down by root 2 to come up with root 2 over 2 as required. Then question 3 says, without using mathematical tables or a calculator, find the value of this. So you write the given expression and also expand. Remember, this is the difference of two squares. So one bracket will have a subtraction, another one will have addition. Then when I simplify, this time this and this cancels. So negative 2 minus 2 gives you negative 4. Then also here, this one cancels. You remain with root 2 plus root 2, which gives you root 5 plus root 5, which gives you 2 root 5. Now this root 5 can cancel with this, and this one, negative 8 over 8, gives you negative 1 as the answer. So that was case 1. What about case 2? Case 2 is the denominator which is in the form a plus or minus b root c. So when the denominator is in that form, where a, b, and c are integers, we multiply both the numerator and denominator by the conjugate surd of the denominator. So conjugate surd means that for this one, it means that this is the conjugate side of this. So you just change the sign. If here there is minus, here it will be plus, and also if here there is plus, here there will be minus. For example, if I have this one, the conjugate side will be a minus b root c, which is here, but you multiply both up and down. When I open brackets, this will becomes this, and this one, the denominator will be difference of two squares, so it will be this squared minus this squared. in the end you come up with this. I think we realize that now the denominator does not have any sides, so that is how they rationalize sides with the denominator of that form. Now let's go through some of the questions. Question 1 says, express this in the form this, and hence find b over a. So in this case, the conjugate side is 3 plus root 2. That's why I multiply it both up and down. Then when you expand, it implies that this times this gives you 9. Then this times this gives you 3 root 2, and also this times this is 3 root 2, so when you add the 2 will come up with 6 root 2. Then this times this gives you 2, which is here. For the denominator, it is difference of 2 squares, so this squared is 9 and this squared is 2. So collect like times this plus this is 11 and this is 6 root 2. Then this one is 7. But I wanted it in this form, meaning that we have to split the numerator. Splitting means that this will be over this and also this will be over that. That's why you see here 11 over 7 plus 6 over 7 root 2. Now that means that our A is this and B is that. Therefore the hence part, B is this, come and put it here, divide by A, which is this. You will come up with 6 over 11. So now we shall go to question 2, which is that without using tables or calculator, simplify that. So this is what is given, and this is the same as 25 times 3, this is the same as 16 times 3, this is the same as 100 times 3, this is the same as 25 times 3. So simplifying gives you that you can split the square roots, then this one gives you 5, this one gives you 4, this one gives you 10, this one gives you 5. So this one, this plus this is 9, and this minus this is 5. So the sides are the same, so they can cancel, remain with 9 over 5, which is the same as 4 over 5. Now shall go to question 3, which is that given this is equal to this, find the values of P, Q, and R. So we're going to start with the left hand side. So this one, you are going to rationalize the denominator to come up with this step. I think we'll see that this was minus and the side conjugate is, sorry, this was plus, side conjugate will be minus. So when I expand, I'll come up with that in the numerator and this in the denominator. So simplify and collect like terms, we'll come up with this, which is equal to that. Then at this step, we have to split the numerator because you should see here it is split. So it be this over this, which gives you that, minus this over this, which is that. Now when I reduce, this can be reduced to become 9 over 11, and this 12 over 33 can be reduced to become 4 over 11. Root 15 cannot be reduced. Therefore, P is equal to this, and Q is equal to that, and R is equal to that. Now we shall go to question 4, which is that given that root 15 is that, root 6 is that, and root 10 is that, without using calculator, evaluate this. So first is to rationalize and then expand both the numerator and also the denominator, then simplify to come up with that. Then from there, remember this initial condition, initial values given, so I'll come and substitute for root 15, substitute for root 6, substitute for root 10 to come up with what is required, and that will be 0.387. Then question 5 says evaluate this given that root 5 is that and root 3 is that. So first of all, I'll get the LCM. LCM will be this times this, which is that. Then this part will be got by saying this times this, that's why you see it here, and also this times this to get this part. So expand and open brackets, you'll come up with this step. Therefore 5 minus 3 is 2. And we are given that root 5 is this and root 3 is that. So I'll come and substitute to be able to get that value. So now we shall go to question 6, which says that express as equivalent fraction with a rational denominator. Express this. So what you are going to do, we are going to first pair. take this one as one term, then you say a minus b gives what? So when you take it as one term, you realize that we will be able to get the difference of 2 squares in the denominator. Then the numerator will be that. So expanding the numerator gives you this, and denominator is difference of 2 squares, so it will be this squared minus this squared. Now when I square this, I'll come up with this part. And when I square this, I'll come up with 5. So in the end, simplifying will give me this part. But remember, the third cannot be left in the denominator, so I have to multiply up and down by this root 6 to come up with this expression. So in the end, I can simplify to come up with this. So that brings us to the end of this video. Thank you for watching, and be reminded that the next video will be on logarithms. So if you are not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video on logarithms has been uploaded. And also, if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that you can all benefit as a family.